Welcome back to the Wartime Military Podcast. On November 12, 1942, in Richmond, California, the SS Robert E. Peary slid into the water just 4 days, 15 hours, and 29 minutes after its keel was laid, a feat that traditionally took nearly 8 months. The maritime establishment, who had dismissed the ship's builder, Henry J. Kaiser, as a naive outsider, watched in stunned silence. But the real miracle wasn't just the ship. It was the workforce of former secretaries, farmers, and housewives who had learned to weld only weeks earlier. Kaiser hadn't just built a ship. He had proven that the mathematics of victory wouldn't be solved by craft tradition, but by industrial revolution. How did this ignorant dam builder and his untrained crews manage to shatter every rule of shipbuilding? Next, we will delve deeper into this story.
Welcome to the deep dive. Today we're looking at a moment where sheer willpower, really, and industrial ingenuity just smashed through centuries of established practice.
We're diving into Henry J. Kaiser and how he completely revolutionized shipbuilding during World War II. It's an amazing story.
It really is. And it's more than just history, isn't it? It's almost a lesson in how to attack impossible problems.
Exactly. You have to start with the context, the crisis they faced back in 1941, the Battle of the Atlantic.
Right. And let's frame that, because this is the core question. How could the Allies possibly hope to sustain themselves, let alone win, when German U-boats were sinking merchant ships way faster than they could be replaced? The numbers were just brutal. Traditional American shipyards, using methods that hadn't fundamentally changed much, took about 230 days on average. That's almost 8 months for one ship.
8 months. And ships were going down daily. The math just didn't work. It was a losing equation.
So how do you solve that? Where does the answer come from?
Well, it comes from someone completely outside the shipbuilding world, a man named Henry J. Kaiser.
The construction guy. Dams? Concrete? Not ships.
Precisely. He'd built huge things, Grand Coulee Dam, massive Pacific military bases, but zero experience with shipbuilding. Yet he was the one who looked at this 230-day average and just refused to accept it.
And refused is putting it mildly. He didn't just tweak things. He took that 230 days and eventually got the average down to, 42 days?
An average of 42 days across thousands of ships. But the really stunning number, the one that just sounds like propaganda but was real.
The SS Robert E. Peary.
Exactly. Launched in just 4 days, 15 hours, and 29 minutes. From keel laying to hitting the water.
4.5 days.
Yes.
It's almost unbelievable.
And that's our mission for this deep dive, right? To unpack how that staggering speed was even possible. It wasn't just about working harder. It involved completely rethinking the process. Prefabrication, welding, using an entirely untrained workforce.
Discarding the idea of the master craftsman, essentially.
Totally. Proving that industrial capacity maybe isn't just about physical limits, but about how you organize, how you think about the problem.
Okay, so let's set the scene more concretely. 1941, the Battle of the Atlantic. Just how bad was it?
Oh, it was existential. Our sources really hammer this home. In 1941 alone, the Allies lost 3.6 million tons of shipping.
3.6 million tons. It's hard to even visualize that amount.
It is. And with ships taking 230 days to build, well, you can see the problem. The U.S. industrial base, mighty as it was, just couldn't respond fast enough using the old ways. The Maritime Commission was, frankly, desperate.
Which opened the door for Kaiser.
It had to. They needed something radical. And Kaiser, already known for huge, fast projects, stepped up. He was arguably the most powerful civilian businessman during the war. People called him the father of modern shipbuilding, even though he started with nothing.
He got his first contract in December 1940, right?
Yeah.
For the British. 30 cargo ships.
Yes, and he had to build the shipyard first. From scratch, on mudflats in Richmond, California. Imagine that.
But the established players, the traditional shipbuilders, they weren't exactly welcoming, were they?
Oh, not at all. They despised him, saw him as a complete outsider, a naive opportunist was the phrase used, a concrete and dam guy messing with their complex craft.
I read that William Francis Gibbs, America's top naval architect at the time, his firm, actually designed the Liberty ship plans. Basically said Kaiser had probably seen fewer ships than Gibbs himself had designed.
Yeah, that level of dismissal, the fact that the government even let Kaiser try his methods, It just shows you the level of panic. It was seen as a desperation move.
So what was Kaiser's big idea? What was the conceptual leap?
He simply didn't see shipbuilding as a unique, bespoke craft. He, along with his chief engineer, Clay Bedford, looked at it like a manufacturing problem.
Like building a car.
Exactly like building a car. They borrowed directly from Henry Ford's assembly line principles. The core inefficiency wasn't materials or skill necessarily, it was the sequence.
Building everything piece by piece inside the hull, from the keel up.
Right. One step had to follow the next in a confined space. Kaiser said essentially, no, let's build the components outside the hull all at the same time and then just assemble them.
Which required a totally different kind of shipyard.
Completely. The Richmond yard wasn't designed like a traditional shipyard with cramped ways. It was laid out like a giant factory. Huge open areas for prefabrication, feeding into 7 parallel building ways like assembly lines.
And then there was the biggest technical change. Welding instead of riveting.
Yes. That was maybe the most controversial part. A typical ship back then used almost 1 million rivets.
1 million. Think of the labor involved. Skilled riveting crews, working for weeks.
Weeks of loud, difficult work. Kaiser, having built pipelines, knew electric arc welding. He proposed using that instead. Much faster, potentially stronger if done right.
But the establishment pushed back hard on that, didn't they? Worries about safety.
Massively. The Maritime Commission, naval architects, even the British Navy Vice Admiral Emery Land noted they forbade large-scale welding on warship hulls. They were deeply worried about structural failure, ships cracking apart at sea.
Which sometimes happened initially.
It did. There were some early failures, hull cracks. But the speed advantage was so huge, they pushed through, learned, improved the techniques on the fly. They basically accepted some risk because the alternative, not having enough ships, was worse. Approval came because speed trumped perfection in this emergency.
So the speed came from this parallel production. Break down how that worked. You weren't waiting for step A to finish before starting step B.
Exactly. You shatter the traditional timeline. While the keel and lower hull sections are being laid down on the ways, simultaneously in other parts of the yard, entire massive sections are being built.
Like what kind of sections?
The entire bow section, the whole stern assembly, deck houses, fully fitted out, even the engine rooms.
The engine installation is a great example of this, isn't it?
It's the perfect illustration. Tell us about that.
Well, they use these huge 140-ton triple expansion steam engines. Not exactly cutting edge, but reliable, simple.
And crucially, simple enough to be mass-produced and assembled by workers without years of specialized training. They deliberately didn't choose more complex, high-performance engine.
Right, so instead of painstakingly building this engine piece by piece inside the cramped engine room over, say, 3 weeks.
Which was the standard way.
Kaiser had teams assemble the entire 140-ton engine structure, boiler, pipes, foundation, everything in a separate workshop. Tested it right there.
Like a giant Lego block.
Exactly. And then, when the whole section was ready on the ways, these enormous cranes, Borley cranes they call them, would just lift the entire completed, tested engine assembly.
140 tons of it.
And lower it into the engine room as a single unit. An 8-hour operation, maybe?
Instead of 3 weeks of cramped, sequential work, that right there shows the whole philosophy shift. It's modular, it's parallel.
Now, to make this work on such a massive scale, building 3 ships a day at the peak, you couldn't rely on traditional skilled labor. There just wasn't enough of it.
Absolutely not. This is where the workforce revolution comes in. Kaiser basically threw out the whole concept of the time-served master craftsman.
How did he staff these yards?
He advertised nationally, offered wages about 20% higher than standard industrial pay, and he essentially said, we'll hire anyone willing to work. Former secretaries, farmers, housewives, clerks, people who'd maybe never even seen an ocean-going ship before.
And training wasn't the old 4-year apprenticeship model, I take it.
No. Training was reduced to about 2 weeks, sometimes even less. But here's the key. It was hyper-specialized.
Yeah.
You didn't learn how to build a whole ship. You learned how to do one specific task over and over again very well. Maybe you only welded vertical seams on bulkheads. That's it. That's your job all day.
Wait a second. 2 weeks training to do welding on a ship that has to survive North Atlantic storms and potential torpedo hits. That sounds risky. Didn't they worry about quality? Weren't there issues?
There absolutely were worries. And yes, as we mentioned, especially early on, there were some weld failures, catastrophic hull fractures. It was a known risk. But Kaiser's bet, the government's bet, was that the sheer speed and volume were worth that risk.
Build them faster than they sink and learn as you go.
Precisely. They gathered data from failures incredibly quickly, refined welding procedures, improved inspection, all while maintaining that incredible production rate. It was iterative improvement at wartime speed.
And this need for anyone who could do a specialized task led to a workforce composition that was pretty unusual for the 1940s.
Very unusual. At the peak, Kaiser's yards employed around 196,000 people. Over 40,000 of them were women. In Richmond, women made up something like 27% of the production workforce. Rosie the Riveter became Wendy the Welder.
And significant numbers of African Americans, too, in skilled roles.
Tens of thousands. Working as welders, crane operators, electricians, skilled positions that were often closed off to them in more traditional industries or by discriminatory unions. Kaiser's need for bodies who could learn one task quickly broke down some of those barriers, purely out of necessity for speed and volume.
So this specialization democratized labor, in a way.
It did. It challenged the old hierarchies based on long apprenticeships and guild control. If you could do the job, you got hired.
Okay, so the system is in place, the speed is ramping up, and this led to a sort of internal competition.
Oh yeah, a very public rivalry between Kaiser's own yards. They kept trying to beat each other's speed records. The previous record was around 10 days, set by the Joseph N. Teal.
And then came the big one, the SS Robert E. Peary, November 1942. This feels like part industrial process, part publicity stunt.
It was definitely both. They needed to prove the concept in the most dramatic way possible. So for the Peary attempt at Richmond Yard #2, they pre-planned everything.
Staging all the parts?
Every single piece. 14 million pounds of components, all fabricated, ready, waiting near the ways before the keel was even laid down.
And the prefabrication went to an almost absurd level, right? Like the deck house.
The 250-ton deck house, yeah. They didn't just build the structure. They fully outfitted it, installed the bunks, the plumbing, the wiring, apparently even hung mirrors on the walls.
Well, I was still on the ground.
While it was still on the ground. Then, because even their giant cranes couldn't lift the whole 250 tons at once easily onto the ship, they cut the finished deck house into 4 large, manageable chunks, maybe 60, 70 tons each.
Lifted those sections onto the ship's deck.
And then just welded them back together right there on the ways. Minimal finishing work needed on board.
Incredible. So the clock starts, keel laid November 8th, 1942, just after midnight.
12:01 a.m. And then just continuous, relentless assembly, shift after shift.
And launch.
November 12th. 4 days, 15 hours, and 29 minutes later, a fully assembled, seemingly operational ship slid into San Francisco Bay.
What was the reaction?
Astonishment. Competing shipyard owners were there, government officials, Navy brass like Admiral Land. They saw it happen. Land himself reportedly said something to the effect that 3,000 years of shipbuilding tradition had just been made obsolete.
It's hard to argue with a ship built in under 5 days. It wasn't just manufacturing. It felt like, I don't know, a magic trick of logistics.
It really did. But behind the magic was this relentless systemization.
And the strategic impact of this system beyond the record was immense, the sheer number of ships.
That's the critical point. The Peary was spectacular, but the real victory was the volume. 2,710 Liberty ships eventually built across 18 different yards using these methods.
What was the peak production rate?
By 1943, American shipyards were launching, on average, 3 Liberty ships every single day.
3 a day. That's the kind of industrial muscle that chokes off a submarine campaign.
Exactly. It overwhelmed the U-boat's ability to sink them faster than they could be replaced. Volume won the Battle of the Atlantic, enabled by Kaiser's revolution.
And the impact lasted long after V-Day, didn't it? These techniques didn't just fade away.
Not at all. Kaiser's methods, large-scale prefabrication, modular construction, extensive use of welding, assembly line sequencing, became the global standard for shipbuilding after the war.
So other countries adopted this.
Absolutely. When nations like Japan and South Korea rebuilt their industries in the 50s and 60s, aiming to become maritime giants, they didn't go back to rivets and sequential building. They studied and explicitly adopted Kaiser's system as their foundation. His methods underpin modern shipbuilding worldwide.
There's also that unexpected but huge civilian legacy, Kaiser Permanente.
Right. Kind of a side effect, almost. To care for this massive, suddenly assembled workforce in remote shipyard locations, Kaiser teamed up with the doctor, Sidney Garfield.
And they set up a prepaid healthcare plan. Pay a little bit each payday, get comprehensive care when you need it.
A radical idea, then. And that system, born out of the wartime necessity of keeping tens of thousands of workers healthy and on the job, evolved directly into Kaiser Permanente, now one of the largest HMOs in the United States. Amazing spinoff.
And the ships themselves, they were designed as emergency ships, expendables almost, right? 5-year lifespan expected.
That was the design spec. Build them fast, build them cheap, expect them to last maybe 5 years if they survived the war, but they turned out to be remarkably sturdy.
How many were lost?
Only about 7.4% were lost to enemy action, which is lower than many expected given the threat environment. And many Liberty ships served for decades after the war, carrying cargo all over the globe.
And incredibly, 2 are still operational today as museum ships.
That's right. The SS John W. Brown in Baltimore and the SS Jeremiah O'Brien in San Francisco, you can still visit them, even sail on them sometimes, living monuments to that industrial effort.
So when you boil it all down, the story of the 4-day warship, the Liberty ships, it's a powerful lesson.
It really is. The core insight seems to be that huge leaps forward often don't come from just doing the old things slightly better. They come from fundamentally questioning the old ways, discarding assumptions, even centuries of tradition.
Kaiser proved complex things that seemed to need years of craft knowledge, could actually be broken down, systematized, and mass-produced incredibly quickly with a rapidly trained workforce.
It shifted the bottleneck from individual skill to organizational design and process engineering.
Admiral Nimitz, the Pacific Fleet commander, famously said the Pacific War was won as much in the shipyards as on the beaches.
And he was right. That industrial capacity unleashed by Kaiser's thinking was a decisive weapon. It proved capacity isn't just about raw materials or even skilled hands. It's about the system, the concept, the willingness to organize differently.
Which brings us to the final thought for you, our listeners. Thinking about Kaiser's legacy, what are the impossibilities in your world, in your field, that maybe aren't physical laws, but just conventional wisdom, just the way things have always been done?
What traditions or assumptions are holding back a leap forward, waiting for someone, maybe an outsider, maybe you, to look at it and say, why does it have to be this way?
That feels like Henry Kaiser's enduring challenge to all of us.